Dagster Running Dagster, where we talk about Dagster Open Platform, our internal usage of the Dagster data platform. Can you go to the next slide? We have myself, Colton Patton. I'm a developer advocate here at Dagster. Alex Noonan, he is here, but his power just went out, unfortunately. So we'll see if he can come online a little bit later in the presentation, but he'll be here to help answer questions. And then we have the one and only Nick Roach, who is our data engineer, who has written a number of numerous pipelines on our platform, on Dagster Open Data Platform. Without further ado, Nick, how about you start talking about Dagster Open Platform?
Yeah, let's do it. Hi, everyone. I'm Nick Roach. I'm Dagster's internal data engineer. Colton said I'm here to talk about how we use. And Noonan are here, like he said. They'll be fielding questions in the chat and making sure they get answered. I'm open to keep this a pretty open discussion just as we walk through everything. Would prefer to this to lean more Q&A than just me talking through a bunch of slides and walking through the UI. So if you have any questions about how we use the platform or anything I present, don't hesitate to throw it in the chat, and Colton or Noonan will bring it to my attention and we'll talk it through. So to get started, excuse me, sorry about that if you can see that in my window. Here's the kind of structure I'm planning to go through during the presentation. We'll briefly discuss data at Dagster and how our data team powers all the different teams at Dagster, why our data platform is important, how data gets used across Dagster, what Dagster Open Platform actually is, and what that means for us internally as a data team, and what it can mean for you as somebody who might be trying to learn Dagster right now. We'll do an overview of the data platform as a whole, the 30,000-foot view. We'll go through the project structure and how we organize Dagster code. We'll look at data ingestion, how we actually pull data in, and then we'll talk through a little bit of transformation with DBT and how we enrich some of those DBT models and DBT assets with Dagster. And then we'll do a deep dive into one of our data pipelines, a specific data pipeline. We'll talk through the problem, how we solved it, the broader architecture. Then we'll talk through how Dagster's capabilities aligned with that pipeline and how Dagster tools make it easy to make that pipeline more efficient, more observable, more manageable. And then we'll conclude with more Q&A. But again, please don't hesitate to ask questions in the chat if you have them. So right off the bat, I just want to talk a little bit about the data team and how we interact with almost every part of the business at Dagster. We help our marketing side understand content performance, like these webinars, and track what channels drive people to Dagster Plus. We help analyze our sales pipeline, our enterprise sales pipeline, to identify areas of growth and track metrics about win rate and contract value and all that stuff. We ingest data from the Dagster Plus application and segment to understand how people are actually using Dagster day to day. And with our R&D team, we're an internal customer of Dagster, so we work pretty closely with R&D to test out new features, provide feedback, and help integrate experimental features like components into the data platform, which is something we're working on right now. And all of this is powered by what we call internally Dagster Open Platform. And so what is it? It's a few things. It's first off our internal data platform. It is the project that contains all of our internal Dagster code. It's our internal Dagster instance and all the supporting code that powers ingestion, transformation, reverse ETL, reporting. It's also a test bed for new features. Like I said, when R&D is developing stuff like components or any new feature, we try our best to integrate them into Dagster Open Platform and provide feedback on what works well, what needs improvement, what we like, what we don't like. But my favorite part about it is that it's an open source code base. It's available on GitHub for anyone to explore and look through. It's a great learning resource for trying to learn Dagster and learning how to productionize it. And we obviously filter out all the sensitive stuff, but most of what you need to run Dagster is in there. And it includes examples of how to use Dagster with tools like Sling, DLT, High Touch, Fivetran, all kinds of stuff. So I'm sure Colton will link that in the chat, but please check it out if you're looking to dive a little bit more deeply into how we use Dagster at Dagster. So that's at a high level what Dagster Open Platform is. Quickly, I'd like to dive into an overview of the data platform, talk a little bit about project structure, how we ingest data and transform data, and then we'll do a little bit more of a deep dive into a data pipeline that I think is a good example of how we use Dagster at Dagster Labs. Colton, maybe you can speak to this a little bit. We can talk through this a bit more in detail, but
Sure.
the structure of Dagster projects evolved over time and been discussed at length. I think we've started to converge on maybe what the best way is to manage all of these different Dagster like objects is the way I think about them, assets, jobs, resources. And the approach that Colton and I landed on that we discussed at length was to start grouping things by the technology, the integration associated with the object. So, for example, we ingest data with Sling via Dagster's embedded DLT integration. So therefore, we group all of the assets, asset checks, schedules, all the configurations associated with Sling into one Sling directory. And it prevents us from jumping around as much as we used to when we were separating things at a high level by Dagster object. We find that by grouping things by these technologies, we're generally working in one of these technologies at a time. And if we need to jump around a little bit, we can, but this kind of houses everything in one place for us to focus on.
Yeah.
And oh, sorry, go ahead, Colton,
Well,
if
I
you
was
have
gonna
more to
say,
add there.
yeah, that's right. I think it's like personal preference when it comes to project structure, but there's some
Mm,
ways that like we found it to be more comfortable than others. You can also imagine grouping it by different teams
mhm.
or different individuals and what they own. But we found to find what you want to work on most easily, we would break it down by technology and then broken down by different files within there. And then we have separate definitions for each of these technologies. So if you recall in Dagster, you create a definitions object that includes your assets, asset checks, all these different things. And then we merge those all in the top level definitions. But yeah, by having it in this structure with technology, we were able to find what we're working on really quick.
And I think that definitions piece is a little underrated, just to touch on that a little bit. Like this ability to not have to think about all of my definitions in one massive definitions.py file and think about them incrementally, like within each of these sort of technologies. It allows me to think a little bit more modularly, and it just cleans up the code base so much. I love where we landed on this. And I believe it was actually your idea, Colton, to start grouping by integration. And it was perfect. And then like if the code is small enough, usually we try to break things out by Dagster object within these different technology directories. But if it's small enough, like our Slack integration is not a very big code base, it's a pretty small file. We'll just put it in one definitions.py file in the directory. But generally speaking, the code is large enough that we usually have to split things out, and it just makes it more manageable when we're making changes. So that's how we structure the project. Would love to talk a little bit about ingestion and transformation, then we'll dive into a specific pipeline. So most of those technologies that you see that we group by in our Dagster project are used for ingesting data from some source system that we pull into our data warehouse. And I'd like to talk a little bit about each of those and why we do that. We use a lot of different tools for ingesting data for a few different reasons. Number one, like I've mentioned before, we're testers of the product and we're trying to make Dagster better. And we want to make sure that we're trying out a broad spectrum of the tools that Dagster integrates with to make sure that they solve the problems we need to solve and they integrate well with Dagster as a product. But also just different tools are better for different problems. And Dagster allows us that flexibility to use the right tool for the right job. So that's the reason we do that. And generally for ingestion, we're using automation conditions. And if you're not familiar with automation conditions, Colton maybe can link some documentation in the chat. But we use automation conditions to power that ingestion, usually powered by a cron job. Most of that data is pulled in on a daily basis. And there's some data that's a little bit higher urgency or higher volume that we need to pull in a little bit more frequently. Like our event log data comes in at a very high rate. So we try to pull that more frequently to stay up to date. And we have some data on the marketing side that's needed a little bit more frequently. So we run that more regularly, usually hourly. But for the most part, our data is pulled in daily. Diving into transformation a little bit, I'll briefly touch on this because it's relatively straightforward. But I think the interesting part about our DBT project is the metadata and the sort of changes we make to better integrate our DBT project with Dagster to sort of enrich it. And I can show some of this in the pipeline demo if that's something people are interested in. But DBT acts as the transformation layer for all of the data that we bring into our data warehouse. And we model it through several layers of data modeling. And the cool part is that we enrich these DBT assets with extra metadata that sort of makes it easier to navigate in Dagster and get to where we need to go. So, for example, we always rename our asset keys in DBT to align with where they land in Snowflake, that database.schema.table name. If I'm in Dagster and I see an asset and I see that asset key, I can pretty much guarantee that exact location is where I'll find it in Snowflake, where we land all of our data. We also group all of our assets by the schema they'll land in within Snowflake. Just makes finding and selecting assets much easier in the Dagster UI. And then we provide a link to the actual object in Snowflake within the Dagster metadata. So if I'm looking at a DBT asset in Dagster, I can quickly get to that same outputted table in Snowflake. Colton, did you have more to add there?
Not on the DBT portion, no. I actually think we might want to hop back to the ingestion just to talk a little bit
Yeah,
more. We
please.
had some users asking like how we decided to go with the different ingestion tools that we did. I know we're big advocates for the embedded ELT tools like DLT and Sling, but we are using several other tools still as well. So I was curious if we could talk a little bit more about that and how we decided to use the tools we did. And then there are also some questions around more event-driven ingestion. And I think we can talk a little bit about how we're bringing in more near real-time data from S3, but we don't have any true streaming jobs, I don't think, right now on the platform. But yeah, first, can we talk a little bit about like, the technologies that we're using?
Yeah, sure. I like I said, sometimes we're splitting out technologies just because we want to be able to try these things. But in the case of like Sling, for example, we just thought it was a good tool for the job when it came to pulling data from our application data lands in Postgres. And Sling makes it very easy to just say, hey, I want to select all of this data from a Postgres table and land it in some other database, in this case, Snowflake for us. So it just seemed like a natural fit to go database to database. If you want to read more about how Sling does that, I would recommend it. It's just a good tool for the job. And then there were some where it was just like, I don't want to have to deal with constantly changing APIs or writing really custom code to deal with how to ingest data. Our application database isn't changing that much, but Salesforce is, and HubSpot is. And I would rather pay Fivetran a little bit of money to handle that sort of abstraction for me
Yeah.
and pull that data for me rather than having to continue maintaining and updating code.
Yeah.
So
And
those
then,
are a couple examples.
yeah, exactly. And then like you said, Sling is good for like database replication, and DLT can do it as well. But I've found
Mhm.
that DLT works best in my use for API ingestion.
I
And
agree.
so a lot of times we'll use DLT for that. And they have a lot of verified sources already pre-built that you can leverage, or you can write your own, and it works pretty well.
Yeah,
Yes, we use a combination of that. And then we also have like data flowing into S3 that we're replicating
that's
part
right.
with like very granular partitions. And we've done kind of like more real-time streaming with sensors in the past, but I don't think we have any running right now. But yeah, using multiple sensors with a cursor to track, say, a Kafka topic is something that can be done if that is something you're trying to do.
And we'll actually talk a little bit about that S3 ingestion in a little bit. That's one of the pipelines I'm discussing at the end of this, Colton. But for more real-time data, we're ingesting telemetry data, for example. We're not pulling that in streaming. Generally, what we're doing is we're landing that data in a bucket, an S3 bucket. Then we have a Snowflake stage hooked up to that bucket, an external state, an external table downstream of that. And then we just have to refresh those Snowflake assets, and we have the latest data from that telemetry bucket.
Yeah,
So that's how we handle streaming data right now. We're not doing anything real time within Dagster at the moment, but we're handling that real time data through a batch refresh of those S3 buckets. And we do that in a couple of different places, but telemetry is just an example. Yeah.
nice. Thanks.
Cool. Yeah. Want to keep moving or any other questions, Colton?
Yeah, let's keep on trucking.
Let's keep doing it. I think I talked through DBT enough. Unless anybody has any questions there, please post them. But I think now I'd like to talk through a specific pipeline. That was a broad 30,000-foot view of the data platform. And I want to dig a little bit deeper and talk about a specific project we worked on, the actual problem we were trying to solve, the challenges we had to overcome when pulling that data in, and how Dagster's feature set really aligned well with what we were trying to do there. I'll talk through the problem briefly, and then we can dive into the solution, and I'll show you some UI and what it looks like in Dagster at the end. We have all of these organizations that use Dagster Plus, right? And all of these organizations can have as many deployments as they want, prod, dev, test, stage. And within those deployments, they can have code locations, which are like specific places to store all of those Dagster objects, right? And every day we take snapshots of these code locations. in Dagster Plus, and these are JSON snapshots of all the metadata associated with a code location in Dagster. They're primarily used for feeding parts of the user interface, the Dagster UI, but they're a wealth of data and information for us about how people are using Dagster, what kinds of assets they're building, what percentage of them are DLT or DBT, what percentage of them are Sling, how many assets have tags on them, how many are using automation conditions. It's just this wealth of how people are actually using Dagster feature sets, right? And it's a great resource for our product team that they were interested in bringing in because they could understand how people were adopting and using specific features of Dagster. However, there were a few sort of challenges with bringing this data in. First of all, it was huge and not well structured. Like I said, it was primarily for bringing into the UI and using in the UI, not for ingesting as a data source. So there were these massive one file per code location files that could be as large as 50 megabytes, just depending on how many assets were in the code location. And there are many organizations with many deployments with many code locations, and that amounted to a ton of files, thousands of files to process. And we obviously want to do that in a reasonable amount of time, preferably with some level of concurrency so that we can parallelize this work a little bit. And then if something goes wrong, we don't want to start over from scratch on that given day. If we process thousands of organizations, a couple thousand organizations in one fails, we don't have to start from organization one and then work our way back up. We prefer to be able to just start from where we were. So those are some of the challenges, and I'll talk through a little bit about how we actually solved that problem. So first of all, we have to break down these JSON blobs. They were massive. And so our thinking was that eventually downstream of this, we want Snowflake to ingest sort of common objects. And so we want to collect all the assets, all the jobs, all the schedules into these separate directories so that we can have individual tables that collect that data into Snowflake. And so our approach was to take these big JSON files and just break them down into one file per Dagster object type, an assets.json, a jobs.json, a resources.json, and so on, all separated out. And then we could group them into directories in S3. All of these jobs, JSONs into their own sort of directories. And then we could connect up Snowflake stages to these directories, refresh those stages, connect those to external tables that we could select from. And now it's just plumbing. Now we can connect DBT up to these external tables as a source, and we can model them downstream. And now it just comes down to building all this out in Dagster and making sure that it runs efficiently. And Dagster makes it easy for us. So this is the final sort of architecture, right? And Dagster has a couple of really nice sort of features that make this easy for us to break down, right? First of all, we are able to partition the data in a way that makes sense. We multi-partition that data. And Colton, if you want to provide some context around multi-partition and dynamic partition, either through docs or whatever, please do.
Sure.
But we partition this data by date and by organization ID. So we will run a full day's worth of data, and then we will have a run for every organization that we are processing, right? That allows us to control that concurrency, right? So we can say, I want to run 10 orgs at a time on a given day, or I want to run 15 or 5. And that allows us to control how long we want this job to run, right? It allows us to parallelize this job in whatever way we see fit. And then my favorite part is that we're using automation conditions to refresh that external stage and external table downstream only after all of the org partitions for that day have completed. So these automation conditions are saying, wait until all of the orgs have been processed for this last day, and then refresh these Snowflake objects so that we get all of the data at the time that everything is complete. And then, of course, we use retries to fix any runs that might have failed on a fluke. But even if they fail a second time, we're only breaking, let's say, one organization or two organizations. We're not destroying an entire day's worth of organization processing. We lose an org, and we can go back in there and rerun it or fix the problem should it arise. So that's at a high level. If there's no other questions we want to talk through, Colton, I figure I could dive into the UI a little bit and show people the Dagster UI and how this pipeline looks.
Yeah, there are quite a few questions, but I think we can go ahead and dive into the UI and get to the questions
Okay,
a little
cool.
bit later.
Yeah, we can dive in a little bit later on the Q&A. Cool. So I'm starting off in the asset lineage here. This is the full asset lineage of our Dagster deployment here. We are only interested in, first of all, Dagster Open Platform, but we also need to get to the actual assets that we care about. So I'm going to show off a little bit of our new asset selection syntax that our friend Marco worked on makes it easy to get to, if I can type correctly, get to where we need. So now I'm filtering to just our Dagster Open Platform code location. And then we keep all of these JSON processing assets in a group called AWS. So I'm going to say I want the AWS asset group, and there they are, right? All of these assets represent the different objects we're parsing out of those JSON from the S3 bucket, right? And if we zoom in, lots of partitions going on here, right? These are, again, daily and org partitions. So this is a heavily partitioned asset, all of these. And so if we dive in a little bit deeper into the asset detail of one of these assets, this is the assets asset, that's a little meta. We can look around at some of the metadata we enrich here. We do some count, like just some basic counting and stuff, but we also include the AWS account that this data comes from, the S3 location that we need to go to get to this data. We can see that this runs on a regularly scheduled job every day at 3 a.m. We have a freshness policy attached to these assets that says, hey, if these assets have not materialized in the last 24 hours, then please alert us and let us know so that we can go see what's going on. Like I mentioned, these assets are heavily partitioned. You can see here the latest materialization was 9 hours ago. And we've got this date here and this sort of pipe and then the number. This is the organization ID. So this is just telling us, hey, the last materialization was yesterday and it processed this organization 11880, right? And we can go look a little more deeply at this and say, okay, there's all of our daily partitions. Look at how massive this thing is. And there's all of the organization IDs, right? These orgs are actually dynamically partitioned. And again, Colton, if you want to provide some context there. But so we have Dagster actually using a sensor to go into S3 and look and see what organizations have arrived since the last time we processed this data. And it grabs all those new organizations and adds them to this partition set so they can get processed in this new run.
Yep. I also did want to call out again that it is meta that we're looking at the assets asset, and that can be pretty confusing. But
That's right.
essentially, we're doing some data analysis on Dagster Plus. So we have data related to assets and asset checks and all these different things. So that's why we're looking at the assets asset.
That's exactly right. I probably could have chosen a better asset than the assets asset to look through. But yeah, each of these represents a particular piece of Dagster Plus that we are analyzing, right? So these are all of the jobs for every organization that's building jobs in Dagster Plus, right? And we have access to all of this information. So yeah, I apologize if that's a little bit meta to walk through this, but please, yeah, let me know if you have any more questions about that. So diving in a little bit deeper into this asset, let's look downstream here. And again, like I mentioned, we have these Snowflake stages downstream that pull this data from S3 into Snowflake. And these just work off of refreshing that Snowflake stage anytime all of those organization partitions have been updated.
Yeah. And can you remind me what a Snowflake stage is?
Yeah, absolutely. Basically, it's just a way in Snowflake to reference an external directory of data. So, right, like in this case, we have an S3 bucket, a directory up in S3 that we want to pull into Snowflake. And Snowflake stages just allow us to reference that data, connect up to that data from Snowflake. And then an external table is just allowing us to select off of that stage. So we're basically just able to select data out of that bucket, just like we would a normal table. So just an easy way to connect from S3 down to Snowflake, right? That's all that's going on here.
Yep.
And like I said, all of this is powered through automation conditions. Now, I won't go into too much detail about the actual configuration of this automation condition, but this is something that Owen, the engineer who actually built automation conditions, helped me put together. And all this is saying, I know it looks confusing and crazy, but all of this is saying is, I want you to run every day, and I want you to make sure that the upstream asset, that is this assets asset, is completely up to date with all of the partitions of the latest day filled in. That is only materialize if all of the organizations for the last day have been materialized upstream. And that's all that's going on here. And it works gangbusters. And it's really beautiful how the entire upstream pipeline will run all these organizations. It can take anywhere from an hour to an hour and a half. And then these Snowflake stages will refresh downstream once all of these organizations have been processed. So that's automation conditions. External table runs very similarly to this. Like I said, it's also powered by a similar automation condition that gets executed basically on the same conditions. So Colton, that's the sort of actual pipeline. If we have some time, I guess we do have a little bit of time. I'd like to talk through troubleshooting and CICD and all that stuff, if that's okay.
Yeah, let's do it. That sounds great.
Okay, awesome. We obviously have a few DBT models downstream of this, right? We referenced the external tables upstream to pull that data into our data warehouse. But let's say something breaks, right? Let's say this DBT model breaks, right? First of all, how do we know when stuff breaks? And then how do we fix stuff and how do we ensure that it's going to actually work when we make our change? First of all, we have alert policies set up on all of our assets. So we always get notified via Slack if something goes wrong immediately. But my favorite thing to look at is the asset health dashboard. Now, we've got a few things broken here that you can see that we got to look through, but generally, this is where I go to every morning to see, okay, what stuff is broken today that I need to go and actually go in and fix and investigate and maybe refresh or rematerialize. And so let's say that this DBT model right here that we've been looking at breaks and ends up in the asset health dashboard, or we get an alert that something's broken. How do we, as internal Dagster users, fix this problem? First of all, usually what I'll do is I'll click into the actual run that failed and just try rerunning that job from failure to see if we can get it to kick back on. Was it just a fluke? Usually that's not the case. I'm never that lucky. So usually the way we'll do this is we'll investigate a little bit further, and a lot of times it's either a fix to a particular field or adding a new field or removing some field. And so let's say we want to just add some new field to this DBT model. Like, for example, I've got this little pre-made PR here where I'm just adding a field to this DBT model that's checking to see if this Dagster asset is a DBT asset, right? Nothing special, it's just a basic PR. But let's say it's fixing something in our pipeline, right? How do we know this is going to work? First of all, we've got CICD set up to clone, make a zero copy clone of all the databases that our DBT models interact with in Dagster, right? So right there, we're setting the stage for sort of a sandbox environment for these models to run in. We have SDF checking to make sure that we're adding descriptions and documentation to any new stuff that we're adding to that, adding to these DBT models. And my favorite part is once we publish the PR, once we actually push it and make it ready for review, we'll build these DBT models against these sandbox databases, against these cloned databases, and some of their dependencies downstream to make sure that we're not breaking the model itself, but also any of its dependent models. Sometimes that's not enough, though. And I want to be sure that I'm not breaking anything and Colton's not going to yell at me or any of our data friends are not going to yell at me. And I'll jump into a branch deployment, which is already set up for me. You can see it's associated with our branch that we created and pushed a pull request for. And I'll jump into the asset lineage here. And I'll say, okay, I want to find all of the stuff that I've actually changed. I'm filtering to this changed code version. I want to see only the assets that I have changed in this PR, right? And that filters it down to the guy that I broke, right? And maybe I want to look at all of the stuff downstream of it, right? Expand that so you can see. And now I can say, hey, I want to materialize all of these. I don't want to just materialize a few dependencies downstream. I want to materialize all of it, make sure this pipeline is going to build properly. And now I've got real peace of mind that the change that I made is actually going to fix whatever it is broken in our data platform. And now we can submit it for review, make sure that everything looks good, publish it, and it will get deployed to prod.
And I do want to reiterate that, like, the way this is configured with environment variables, this branch deployment is pointing to a clone of our
That's right.
Snowflake database, a zero copy clone. So it's running on production-like data, but in this separate environment. So you can be pretty confident that it's working as expected.
Thank you for that clarification, Colton. That's the biggest piece of this is we clone prod at the prod database as it exists right now. And these DBT assets actually materialize off of that cloned database. So we're running off of prod data without breaking prod data. That's the really nice part about this. So that's all the content that I had prepared. Colton, unless there are any, I'm sure we've got some questions in the chat that we want to talk through. But that's all I had prepared for us today.
That sounds great. Yeah. So we have another poll triggered now, and we'll go through the questions. The third question on that poll, I'm really interested to see people's responses for. What part of Dagster Open Platform, which we call DOPE, would you like us to explain next? And you're also, if there's some other topic, you can put it in the chat. But we think that it might be really nice to have more of a recurring series of this where we talk about how we're using Dagster internally, if that sounds interesting to you all. Please feel free to give suggestions there. But yeah, we have quite a few questions, and I think maybe we'll try to work backwards. I don't know if we'll be able to address all of them. There are quite a lot. So if we don't address it, we have a deep dives channel in our public Slack that you can talk to us in. But one of the questions here was, what tool do you use for the zero copy clones for these branch deployments, Nick?
Yeah, so this is all done. We actually just changed this a little bit, but effectively we have a couple of stored procedures that have to wrap up all of the commands that we run in Snowflake to build these zero copy clones. Effectively, it's just I want to clone the Snowflake database and give it a new name. And then I need to grant a few permissions after that to make sure that our Dagster service account, the one that's running those DBT models in Dagster, has access to that clone database. And we give access to data engineers and the people who are actually running code, of course, so that they can go in and mess with that database if they want to in Snowflake. But it's basically just a bunch of stored procedures, a bunch of SQL commands that get executed.
Gotcha. Thank
Yeah.
you. Yeah, let's see what's next. There were a few questions actually around factory patterns and
Mm,
generating assets dynamically. We make pretty significant use of this pattern, essentially creating a function that takes in some kind of parameters or specification that then produces an asset and asset checks or any kind of entity within Dagster. Um, can you talk a little bit about like the pros and cons of that? And then do we have any examples still in the code base, or have we migrated a lot of that to components? I will say components is also offering a similar kind of factory pattern approach
that's right.
to creating assets where you encapsulate the generation of the different entities. But yeah, can you talk a little bit more about factory patterns and why you might use them or how we've used them in the past?
Yeah, I'm trying to remember an example of where we have them in the code base right now. But like you said, components is going to be a good sort of swap out for any places that a factory pattern would make sense. But I know for me, when we were using them to a greater extent, it was when we had a situation like Sling is probably a good example of we have a bunch of these different configuration files. They all act the same way, maybe with a few like changes to schedules or changes to metadata. But generally, you're feeding the same information into the assets every time. It's just different information every time. So for me, those factory patterns make the most sense to me when I have very repeatable sort of metadata that I'm passing into an asset every time. I'm just thinking of it as I've got a bunch of stuff that's going to act the same, but maybe they have different names, maybe they have different schedules. And so I'm just going to build a function that generates those assets for me rather than having to repeat myself over and over. Again, components is going to make it a lot easier to do this without having to build a lot of that sort of boilerplate code yourself.
Yeah,
I wish I had an example off the top of my head where we're using factory patterns, but I can't come up with one right now.
yeah. I created an example in the examples folder within the Dagster monorepo of
Mm,
using a factory pattern to ingest podcast data and process it with modal. So there's like a modal example project in there where essentially each podcast would have a sensor, an asset check, and then three different assets. So you'd be able to like generate that pipeline for each podcast programmatically. So that's one kind of silly example of how you might use it. Stephen asked, and we already addressed this, but I'll reiterate it. But Stephen asked, do you have a staging environment? And the answer is we
kind of.
have a couple of deployments of our data platform one that's using more of an experimental, like nightly build of the Dagster software so that we can test and ensure things aren't breaking before we go live. We wouldn't expect other people to necessarily do that. That's more of like internal dog fooding of the Dagster product. And then we make heavy usage of branch deployments, as Nick showed us. So branch deployments in many ways are like our staging environment.
That's right. I see a world where we could have a dev environment for all of our data. Um, but for now, like Colton said, branch deployments take the place of a lot of that for us. And then we have that dog food deployment that works off of latest master Dagster. But that's just to make sure that Dagster is going to continue to work for us in the data platform. And there's no issues that could break anything. Yeah. Yeah. So no specific staging environment right now. Dev deployments or branch deployments take the place of that for us right now.
Yep. This is a kind of interesting question. Carl asked, are there any features of DLT or Sling that are redundant within Dagster? Which features do you
Hmm.
leverage most? I think like you essentially could replicate a lot of what they're doing just with vanilla Python, but there's not really much benefit in doing that. I think it's often great to just leverage the open source ecosystem and use these tools that solve one job really well and then compose these different tools together. And that's what we found with DLT and Sling is that they have handled the hard part for replication and ingestion for us. And then Dagster can really handle the orchestration on top of that.
That's right. Generally, the reason I go for some of these integrations, particularly ones like Sling or Fivetran, is so that I can plug things in, get it connected to where I can see what my how my lineage works, and I have a really nice view into my data platform, and then I can back up and put my hands up and let this thing work the way it's intended, right? I don't want to have to manage my own custom Python code to bring Postgres data into Snowflake. I'll let Sling do that for me, and then all I have to do is run it, right? So that's the way I think about it. So redundancy, you could make it redundant with a Python script or something like that, but I don't know if that's something I would ever want to do just for the sake of maintainability.
Yep. And then we have this question. I'm not sure if we have an answer for it, if it was before our time, but how did Dagster Labs make the architectural decision to choose Snowflake as our data warehouse over something like Redshift or maybe Databricks? Do you have
Mm.
any insight into that?
Before my time,
Yeah,
unfortunately. I'd have to ask one of the Dagster historians to see who made the decision at the outset.
yeah. I will say Snowflake is nice, how its batteries included, and you don't really have to think about optimizations
Yeah,
for your queries, and you can get up to, and running really fast. But there are cons like cost compared to
yeah,
other technologies. But yeah,
of
we've been
course.
using Snowflake for a while now.
Yeah. But one thing we didn't really talk about too much in this presentation is Dagster Insights, which does make it a little bit easier to monitor some of your Snowflake costs and how you're running things against your data warehouse and stuff like that. And again, maybe in a later series, we can talk a little bit about that and how we use it internally.
Yep. Let's see. Hmm. One user or Amlan asked, can you share an example of how we use DLT for API extraction? I'll send you a link. You should be able to find it in the Dagster Open Platform repo under
Mhm.
the DLT folder. We have a bunch of different ingestion jobs there. So you should be able to find something, but I can
That's
also
right.
send you a link.
We pull HubSpot data right now with DLT. We pull GitHub data with DLT. I think we have at least one or two more other ingestion pipelines with DLT.
Yep. And this user asked, do you use Dagster DBT, the integration to materialize and test DBT assets? And the answer is yes.
That's right.
And then there's the question, have you had the arg list too long error? I do recall people getting that error. I don't know if we've hit it internally.
I'm just now hearing about this for the first time. That sounds awful.
Yeah, I believe a fix was made for that issue. But essentially, the Dagster DBT integration calls the DBT CLI under the hood, and if
Right.
your selector for DBT is too long, it can exceed that which Unix supports. And I believe
I
a fix was made for that. If you're still running into that, please message me. I'd be curious to learn more.
that's crazy given how like I've seen how long our argument list is. That would have to be a pretty crazy long one.
Yeah. Let's see. How do you handle partitions that don't need all assets in a DAG? For example, if you have an account ID partition for an asset, but the asset only matters for accounts that have a specific feature. I'm not sure. I might need more details on
Hmm.
that one, Jared. Do you know what they're asking or have an answer for that one, Nick?
No, I mean, maybe they're. Please correct me if I'm wrong in the chat, but maybe they're asking about connecting assets that are partitioned to assets that are not
Hmm.
partitioned. Maybe, which we. Oh, okay, Colton. It sounds like Jared did ask a second question that might provide
Oh,
better context there.
yeah, it's broke. They have a pipeline that's broken up into multiple assets, and we are partitioned by ID, but it feels weird because all the intermediate steps to get the result, there's no clear bailout. I think actually for this one, maybe if you could just message us in the Slack, we can try to address your specific problem more clearly. Sorry if we don't have an answer right off the top of our head, but yeah, we can definitely chat more. Let's see. This question said, is the max 25,000 partitions per asset guideline still the suggested best practice? We're actually continuing to improve our concurrency and we're trying to increase that limit. Right now, it's just a suggestion. You can do more than that, but yeah, there are optimizations happening under the hood to increase that as we speak.
I can tell you we're breaking that rule. I know that's the suggestion, but we internally are currently breaking the 25,000 partition rule with the pipeline that I just showed you guys.
Yep. Matt Manzinski asked that he said he's very interested in the idea of using Dagster to land data in S3 directories and mounting those as Snowflake external stages. Are there documented
Yeah,
best practices or conventions for doing that kind of pipeline? Yeah, I'm actually curious, Nick. When you came up with this solution, were you referencing any other guides online, or how did you come up with this?
I was first of all there. I have not noticed any Dagster documentation on this, and we should probably put something together. If not, please check out the repo and everything to see how we've got this set up. I have used stages and external tables in the past just to connect stuff to S3. Dagster just made it easier to orchestrate all the pieces of that. So I don't know that I've used external stages and external tables to the extent that I've used them here, but I've always seen them as a great tool for saying, okay, I'm in Snowflake. There's some external data somewhere that I don't want to have to batch process directly into Snowflake. I'm just going to hook Snowflake into this external data source so that it knows where everything is, and then I can have Snowflake process that data directly. Yeah, I don't know that we have any documentation explicitly on this, but maybe Colton, you and I can work
Yeah,
together on something to because I think it's a great ingestion scheme for stuff that's already getting landed in S3, or you want to do the processing elsewhere, landed in S3, and then just have Snowflake process it for you.
yeah. We
It's a
can
good tool.
we can definitely create a reference architecture for doing something like that. We're hoping to make more of these reference architectures moving forward, and if you have any suggestions for those, feel free to let us know, but that would be a great one. Okay, I don't think we'll be able to address all the questions. I thank everybody for asking them. I think we'll rapid fire maybe three more, and then feel free to reach out to us on Slack or GitHub discussions if we didn't answer what you need. Bill asked, does your data platform feed into ML algorithms at all? Not LLMs, but tabular ML algorithms. And I don't think we do at this moment, do we?
It's funny he's talking about that. We're building one, like our first sort of version of this right now. Anil, our data analyst, and myself are working on productionizing an ML model right now. It's pretty basic. It's like we're not going into SageMaker or anything at the moment. It's just going to be having a Python script reference some training data that's sitting in Snowflake, and then it will write out the output of that sort of prediction model in back into Snowflake again. So it's pretty rudimentary, just a basic, let's get something up and running, an ML pipeline in Dagster, and then we'll probably iterate on that. And once we feel like it's proving value, we'll maybe push it up into something that's a little bit more purpose built for managing ML models.
Nice, thank you. Christoph asked, have you tried Mother Duck in any of your pipelines? And we have, yeah, it's worked great. I really like using Mother Duck in that you can use DuckDB locally for testing, and then it's essentially the same exact thing running in the cloud with Mother Duck. So if you're looking to use it for your pipeline, I think it's a great choice, Christoph.
Yeah,
All right, last one. What do we use for reverse ETL?
high touch. Pretty
High touch.
much exclusively high touch. That's not necessarily true. We push some data back into into an application database to power insights at the moment. And that's done with Sling. We just say, hey, we've got some data. And so we're basically doing the reverse of what we do to ingest data from Dagster's application DB, but we're sending it back up to Postgres. So we're saying, hey, we've got some data in Snowflake. Let's use Sling to send that data up into a Postgres database for reporting in Dagster. So those are the two tools, pretty much exclusively Sling and high touch.
Awesome. This was really great. Thank you so much, Nick. And thank you, everybody, for asking so many questions and all the engagement. Somebody asked Colton, are you just vibe coding these days? Yep,
Yes. Yeah, pretty
exclusively
much.
vibe coding.
Me too, frankly.
Yeah, we'll try to address the rest of your questions. Feel free to message us on Slack. We'll try to make this a series. It seems like people are really interested in how we're using Dagster internally, which is awesome. So thanks again, everyone. And again, this will be on YouTube shortly, and we'll be seeing you guys soon. Thanks,
Thank you
everyone.
guys so much.